construct ellipse by concentric circle method. So ellipse, as you have already studied in HS, ellipse has got a minor axis and a major axis. Major axis is the major one, that is the bigger one, and minor axis is the smaller one. So here it is given 80 mm, 60 mm. So firstly, what we have to do, we have to construct two circles or concentric circles. Concentric circle means both the circles will have a common center. Both the circles will have a common center. So from the center, by taking the diameter, I repeat again, by taking 80 mm and 60 mm diameter, so the radiuses of circles will be half, 40 meter and 30 meter. So with 30 meter and 30 mm and 40 mm radius, we need to construct two circles with the same center. Now once the circles have been constructed, now you have to draw the axis, the horizontal one and the vertical one. Okay, so two circles have been drawn and two major and minor axes are drawn, and you know that the full angle for a circle is 360 degree. Now what we have to do, we have to divide the 360 degree into 12 equal parts. Okay, so the circumference of the circle is to be divided into 12 equal parts. So one small division will become 30 degree. So starting from any one of the vertical or horizontal axis, we need to draw 30 degree angles. Okay, so starting from, let us say we are starting from here. So from here we have to take 30 degree angle and we have to draw a line through the center. Okay. So this inclination is 30 degree. Okay, this inclination is 30 degree. So again with this line we have to draw another 30 degree inclined line. Okay, so this angle is 30 degree, this is 30, this is 30. Again, with this line, we have to make a 30 degree angle and draw a line through the center. Again, with this line, I have to draw another 30 degree line. So now you can see the circumference of the circle has been divided into 12 equal parts. If you count the, now what I have to do here, let me use another pen color. So from the bigger circle, I have to draw the vertical line. I don't know the length as of yet. And from the smaller circle, the intersecting point between the inclined line and the smaller circle, so from this point I have to draw a horizontal line. Let us say those both lines will meet at point P1. So this is the point of the curve. So this is the one point of the ellipse. Okay, so P1. So I repeat again. So from the first inclined line, let us say it is one line. From the first inclined line, so this is that inclined line cuts the bigger circle here. So from that point, we have to draw a vertical line, and that one line has cut the smaller circle here. So from that line, I have to draw a horizontal line, and both the horizontal and vertical lines meet at point P1. I have to repeat the process for the, let us say this point is 2, from 2 also. So vertical line, I don't know the length, and from that point, I have to draw the horizontal line. So okay, another point is obtained. So this point, let us say P2. Okay. Now, so see, now let me give names here, then you will understand it better. So let us say AB is the major axis and CD is the minor axis. So the one point on the curve is C. So the four points before even the division of the circle being made, the inclined division of the circle being made only with the axis. So we have got 4 points C, B, D and A, B, C, D have got points. So these are the 4 extreme points of the ellipse. But with the 4 points, it is very difficult to draw ellipse. So we need to find more and more points. Okay, so that's why P1, P2, the points are found. Okay. So let us say B is 0.3, then 0.4 is here. Now 0.4, from 0.4 from the bigger circle, a vertical line is drawn. Again from the smaller circle, a horizontal line is drawn. So that point will be P4. Again, the process is to be repeated for all the remaining points. Vertical, horizontal. That point will be P5. So 5, 6 is here. So already we have the point D now. So actually we need to apply the common sense, because you cannot draw a vertical line at the bottom. You have to draw a line like that, isn't it? And if you draw a horizontal line here, there is no vertical line to be made. So I have to draw a horizontal line like that. So every time we have to apply our common sense to draw the lines. Okay. So this is 7. Now this is 8. So vertical line and horizontal line. So that point will be P8. This is 9. This is 10. So again I have to apply common sense now. By the common sense I can easily know that the downward line will have to be drawn. And from this point, right to left point is to be drawn. Now this is P10. Now this is 11. So here, like that, and like that. So this is P11. And also this is 12. So that point will be P12. Now if I join all the points starting from P1, P2, then B, P4, P5, then this D, P7, P8, A, P10, P11, and C, then our ellipse will be obtained. Now you have to join this by using French curve, or you can simply join it by freehand. So a continuous curve, that curve has to be continuous one. You have to remember. So you get the eraser. By erasing the curve, you can draw a good curvature of ellipse. But remember one thing, that the continuous curve, no sharp edges will be there. So the curve will almost like that. So other than this curve, all the other lines are construction lines. Please remember that. So all the construction line will be thin, okay, and the curve only will be dark. So please remember that the curve only will be dark, and all the remaining lines, these are the construction lines. So these are thin lines. Now next is the ellipse by oblong method or rectangle method. So again, so major axis and minor axis are dimensions are same, 80 mm, 60 mm. So what we have to do, we have to construct a rectangle of 80 by 60. Okay, with the dimensions of the major and minor axis, we need to construct the rectangle first. Okay, now once the construction being made, we have to draw the two axes like that. So from midpoint here and midpoint here. So this is the major axis, and this will be the minor axis. So AB. So the 4 points of the graph have been found, ABCD. So the ellipse will have to be drawn like that. But with the 4 points, it is not possible to draw ellipse. So we need to find more and more points. So how they are found? Now what we have to do, we need to divide this small line, okay, this small line into a number of equal parts. Let us say 4. So divide that line, that smaller line, into 4 equal parts. I repeat again, these are all construction lines. So that will be thin. Okay, so we have divided this into 4 equal parts. So let us give names. So here 1, next point is 2, next point is 3. Okay, so 1 to 3 points are found. Now we have to join all the points with C. Okay. Please remember the steps. From all the points, you have to join point C. Okay, so 3 lines are found. Now what we have to do, so that half line, half the length of the minor axis has been divided into 4 equal parts. Now this adjacent line to that line we have divided, that half the length of the major axis is to be divided into same number of equal parts. As it is divided into 4, so that has to be divided into 4 equal parts. By drawing an inclined line, again we have to divide 1, 2, 3, 4 into 4 equal parts. Okay. To name the points like that, this is 1 dash, this is 2 dash, and this is 3 dash. As we have given 1 to 3, so hence we will give 1 dash, 2 dash, and 3 dash. Now, okay, next step is to that we have to join D to 1 and extend it up to 1. Okay, so D to 1 being joined, and this line has to be extended up to 1. The same process is to be repeated here, so that point will be P1. The same process is to be repeated now. We have to join 2 dash to D and extend the line up to 2. So that point will be P2. Next, join D to 3 dash and extend the line up to 3. Hence, we will get point P3. Now see, we have found 3 points in between A and C. Now these 3 points and A and C, if we join, then we will get 1/4 of the ellipse. Okay, so 1/4 of the ellipse has been found. Now we have to repeat the same process for the remaining remaining 3 parts of the rectangle, or in shortcut, what you can do, I'm just telling the process. You have to construct a mirror image, or you have to do a mirror image. How does that being done? So from point P1, we have to draw a horizontal line. Okay. Point P2 also, you need to repeat the same process. Draw a horizontal line. And from point P3 also, we need to draw a horizontal line. Okay, now what we have to do, now we have to measure the distance of P1 from the vertical line, from the line CD. Okay, so the distance of the P1 from the vertical line CD is being taken. So this distance starting from this point up to this point, P1 point, we have to take measurement with the divider and cut the point here. Okay, so that point will be named as, let us say 1, 2, 3. So you can give name anything, that does not matter. Let us say P1 dash. Now P2, again we have to take the measurement of P2 from the vertical line CD. So that distance has been taken and a point has been marked here. So P2 dash. Again, the distance of P3 will have to be taken from CD line. Then a point is to be marked. So P3 dash. Now again, between C and B, we have found 3 points. So if we join these 3 points by means of hand or with the help of French curve, then so the half portion of the ellipse has been found. Now you have to repeat the same mirror image concept for remaining 2 portions. So we need to draw a vertical line from P1, again a vertical line from P2, and vertical line from P3. Okay. Now again the similar process from P1. Now the length of distance of P1 from AB will have to be taken, and this will have to be marked here. So let us say it is P1 double dash. Now distance of P2 from the line AB will have to be taken with divider, and this has been marked here. So name the point as P2 double dash. Now distance of P3 will be taken, will have to be taken. Now P3 double dash. Now all the points are to be joined by means of French curve over hands. Then you will get 3/4 of the curve. Now for the last process, for the last remaining portion, then I can draw vertical lines from here, because if I take, you can take also lines, horizontal lines from here, but I am taking line from here. Those are same methods, only I have to apply the concept of the mirror image process. Okay. So again, distance of P1 from AB is taken, is being marked here. So we have taken double dash, so triple dash here, P1 triple dash 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 dash. Then distance of P2, it is P2 dash dash dash. Then P3 from line AB. Now this will have to be marked. So P3 triple dash. Now if we join all the points with the help of freehand or French curve, then the remaining portion of the curve will be found. Now hence the construction of the ellipse is completed. Okay. Now let us move to the third diagram. We have to construct a parabola by a rectangle method. Take horizontal range as 60 mm and maximum height reached as 40 mm. Now you see, I can say here that instead of mm, okay, these distances can be given as meter or anything. Okay, if they are given as 60 meter and 40 meter, then you have to construct that, you have to convert that meter into some suitable scale to mm. Okay, so for that case, if the distances are given as 60 meter and 40 meter, then what we have to do, let me show you. So with with these distances, no diagram can be drawn. So we have to reduce the dimensions. So in that case, RF will have to be found. So 60 meter cannot be taken as drawing length, but 60 mm can be taken as drawing length, isn't it? So 60 mm by 60 meter, if you convert meter into millimeter, then so 1000 mm. So RF will become 1 by 1000. Okay. So you have to construct the diagram with the length 60 mm, not 60 meter, because 60 meter line cannot be drawn. So we have converted the 60 meter length into 60 mm length. Okay. So once that has been converted, you have to write here RF is equal to 1 by 1000. At the bottom of the scale, you have to write RF 1 by 1000. But our drawing, in our drawing, the measurements are directly given as 60 mm, 40 mm. So this calculation is not required here. Okay. Just I have made that calculation for you to understand. So don't do that. Now what we have to do here, now we have to divide. Okay. So you have to take the midpoint of this line. So that point will be the maximum range, isn't it? So let us say this point is A and B, horizontal range is AB, and C is the maximum height reached. So the 3 points of that parabolic curve are AC and B. So the curve will be like that. curve will be like that, but with the help of 3 points, the ellipse, the parabolic curve cannot be drawn. So here some more points have to be found here, isn't it? So more and more points have to be found here. So what we have to do, we need to divide that line into some equal parts. Let us say we have to divide that line into, let us say, 4 or 5, 5 equal parts. The more number of points there are, the curve will be good. 5. We have known how to draw parallel lines, so I'm not repeating the process. Okay. Okay, so that line has been divided into 5 equal parts. So let us say there is 1, 2, that point, 3, and 4. Okay, now this half portion of the AB has to be divided into same number of equal parts, that is 5. Okay, now 1 has been started from here, so that has to be named 1 dash, 2 dash, 3 dash, and 4 dash. So the points have been taken. Now one point has to be joined with C. Again 2 has to be joined with C. Also 3 will be joined with C, and also 4 will have to be joined with C. Okay, so all the points 1, 2, 3, 4 have been joined with C. Now from these points 1, 2, 3, 4, we have to draw vertical lines. So from 1 up to the 1 point, 1 line, so that will be P1, 1 point of the curve. From 2 also, vertical line up to the point 2, up to the line 2, so that will be P2. From 3 also, so that will be P3. So from 4 also, up to line 4, so that will be P4. Now all the points and A and C points are to be joined with thick line. So the half portion of the parabola has been found. Now for the remaining half, we have to repeat the same mirror image concept. So from P1, draw a horizontal line. From P2 also, draw a horizontal line. From P3 also, and from P4. Again, take the measurement of P1 from the vertical line C, so let's say it is D, it is CD. So and cut the measurement here and name the point as, let us say, P1 dash. Then take the length of PD from the line CD, cut it here. It is P2 dash. Next P3, this length will have to be cut at the opposite side, P3 dash, and also P4. You divide that, take the measure distance of P4 from CD line and cut it here, and join all the points with the help of a dark pencil, thick pencil. To draw the complete elliptical curve. Parabolic curve, sorry. So this is the part of a parabola. If a ball is thrown, so the maximum at 45 degree, then the maximum height reach will be at the mid, and it will be a parabolic path. So the parabola has been constructed by rectangle method. Now we have to draw a rectangular hyperbola. This is the special method to draw a hyperbola with the coordinates x is equal to 25 mm and y is equal to 30 mm. So what does it mean? So we need to draw first x and y axis. Okay. So two x and y axes are drawn. Now x is equal to 25 mm means at the x-axis we have to take 25 mm measurement. Let us say this distance is 25 mm. We take another color for you to understand. So that distance will be 25 mm. 25 mm distance is taken, and from that point a vertical line is drawn. And from y-axis 30 mm length will have to be taken, and from that point a horizontal line is to be drawn. So this point will be, let us say P, this point will be one point of the rectangular hyperbola. Okay, so the rectangular hyperbola will go through the point P. Now the next steps are, in the next step what we have to do, we need to take some arbitrary points. Let us say a point is being taken here, here, and also on that line, and on that line also. On that line, let us say we have taken 3 points, and at that line we have taken 2 points. Okay, more points can be taken. So this will only make the curve lengthy. So we will not take more points than this. So 3 points here and 2 points here. Now what we have to do, we have to join this O point to these points. Okay. So 2. Let us say it is 1, it is 2, 3, 4, 5. So from 3 to O, then from 4 to O, and from 5 to O. Okay. I repeat again. So this distance is 30 mm vertical height. So we have to take 25 mm x and draw a vertical line, and 30 mm y and draw a horizontal line. So these two lines will meet at P, and we have to take arbitrary some points 1, 2, 3, 4, and 5. So these 5 points have been taken. Now from point 2, draw a horizontal line, and the 2O has intersect this line here to draw a vertical line from here. Okay, so let us say that point is point 2. Well, let me give the names like that. It will be for better you to understand. Let us say this point is 1, this point is 2, and that point will be pure. Again from 2, horizontal line. I have to apply common sense actually to find the points. So this will be P2. Now this line I have to take. So from here I can draw a vertical line, and from this intersecting point here I can draw a horizontal line. So this will meet at 3, P3. From point 4 also repeat the process. So 4 line is here, so that will be point 4. Repeat the process for point 5 also. So the intersecting point for 5O of the vertical line is here. If the vertical line is here, so that point will be P5. Now, so all the points and P have been found. Now if I join starting from P1 up to P5, including P obviously, then this curve will be a rectangular hyperbola. So this curve is a rectangular hyperbola. So we have constructed firstly the ellipse by concentric circle method, next ellipse by rectangular oblong method, next parabola by rectangle method, and lastly we have constructed rectangular hyperbola with the coordinates given.